When we picture the future, we imagine these super smart, sleek robots, right? But what's funny is that some of today's most advanced machines can get totally tripped up by one of the simplest things you can find in any home.
I mean, this quote from Coda Data just nails it. Picture this, a robot worth millions, that can navigate a maze, that can lift heavy stuff, but the second it walks into a kitchen and tries to use the stove, it just stops. Turning a simple knob is somehow mission impossible.
So, what gives? Why is such a basic task so incredibly difficult for a piece of advanced technology? It seems like it should be easy, but this little problem actually shows us a massive gap in how robots see and understand our world.
Yep, there's actually a name for it, the clumsy robot problem. And it all comes down to this one simple, kind of mind-blowing idea. For a robot, just seeing something isn't the same as actually understanding it.
Okay, think about it like this. When a robot's camera looks at a knob, it just sees a flat picture, a 2D circle. It might even be smart enough to label it knob, but it has no real idea of its depth, its shape, or how you're supposed to grab it and turn it. It's missing that crucial third dimension that our brains process automatically. And that one missing piece is the difference between a helpful robot and, well, a very expensive paperweight.
So how in the world do you fix this? Well, it turns out you don't need a fancier robot. You need a better teacher. And in the world of AI, that teacher is a really, really specific set of data that's built to solve this exact problem.
And here it is. It's called Appliance Knobs. It's an open-source dataset that's laser-focused on one single thing, teaching robots how to get a grip, literally, on dials, knobs, and other rotary controls. Think of it like a textbook, but just for one of the most annoying objects a robot has to deal with.
This whole thing was put together by the team at Codata, and what's really cool is they've made it totally open source and put it up on Hugging Face so anybody can use it. That kind of teamwork is exactly what's needed to crack this problem for everyone in robotics.
So what's the magic trick here? What makes this particular collection of images so special? How can a bunch of pictures teach a robot to see in 3D? Well, the answer is actually brilliant in its simplicity.
Here's the secret sauce. Every single knob in the dataset is photographed twice, once straight on from the front, and then again from the side. This one simple move is like giving the robot a second eye. All of a sudden, it can perceive depth and shape.
It's a total game changer. With just one angle, the robot sees that flat circle we talked about, but with two angles, bam, it perceives a cylinder, something it can actually grab. It goes from being totally clueless about depth and shape to understanding the object in physical space. It's the jump from just seeing to truly understanding.
Now, the fancy term for this is 3D shape reconstruction. Basically, the robot's AI takes those two flat pictures and uses them to build a little 3D model of the knob in its virtual mind. This gives it a digital blueprint so it can plan out its moves, figuring out not just what the thing is, but how it exists and works in the real world.
Okay, so the robot has its 3D blueprint. Now what? This is where the data turns into action. This is how we get robots that can finally actually function in our world.
Let's walk through it. First, the robot uses multiple views to recognize, aha, that's a stove knob. Second, it builds that 3D model to understand its shape. Then, third, and this is key, it figures out the knob's current position. Is it on high? Is it on low? Is it off? And finally, all this amazing data gets fed back into training the next generation of AIs, making them even smarter.
So after all that complexity, the AI, the computer vision, the robotics, it really all comes down to a single powerful idea. One dataset. One totally overlooked everyday object. And one giant leap for getting robots to actually work in the real world. I mean, this isn't just about turning on a stove, right? It's about building machines that can safely and reliably do things in our spaces. So the next time you turn a dial, just remember, that simple little twist is a way bigger challenge and a much more important step toward our robot future than you probably ever thought.